Welcome to this session on problems of DFT properties. So we'll solve some problems on DFT properties. Already we have discussed various DFT properties, and this particular point we have to in this particular point we have to solve some problems on DFT properties. So here are the few properties that we have already discussed. That is nothing but linearity property, periodicity property, circular time shift property, circular time reversal, symmetry, circular convolution, and Parseval's energy theorem. Then those are the nothing but properties. Linearity property. Then we have periodicity property. If input is periodic, that is x of n is periodic, then output, that is x of k, is also periodic. Then we have discussed circular time shift. So if x of n having DFT x of k, then x of n minus L will have DFT x of k into W and thus to Lk, that is Lk. So it is called as circular time shift property. Then we have discussed circular time reversal. Then it is circular convolution property. It means that if suppose x of n having DFT x of k, h of n having DFT h of k, then convolution in time domain, that is x of n circular convolution with h of n having DFT x of k h of k. Then next is Parseval's energy theorem. So we'll solve few problems on those properties so you can understand more about that properties. Now first point, now we'll solve the first problem on the property of DFT. If suppose x of n is 5, 2, 3, 4, find DFT of x of k. Okay, read this problem carefully and using result of above and not otherwise, find DFT of x1 of n is equal to 4, 5, 2, 3, and using result of above and not otherwise, find DFT of x1 of n, x2, you can write x2 of n is 5, 4, 3, 2. Okay, now what is x of n is given, you can write the x of n. X of n is given as 5, 2, 3, 4. Now what you have to do, the first part of this problem is you must calculate DFT of it, correct, DFT of it. And in second and third part, if suppose you can have, this is first part, this is second part of the problem, this is third part of the problem, then in this first part of the problem you must calculate DFT of that by using the matrix method. Okay, and in second part or third part of the problem, you have to use the result of first one. You need not, it means it is compulsory to use result of first one and use of the property. It is said that using result of above and not otherwise, find DFT of x1 of n is equal to 4, 5, 2, 3. Okay, so it means that you must use the result of above in the section second and third, or in the bit second and third. You can't use the matrix for finding the DFT. Okay, so we'll begin with the first, that is x of n is given. Now we can solve the problem. Okay, so first x of n is given, then find out DFT of this, that is nothing but x of k is equal to, you can use the matrix of DFT matrix and then multiply with the x of n. Okay, the DFT matrix is 1, 1, 1, 1, 1 minus j, minus 1 j, 1 minus 1, 1 minus 1, 1 j, minus 1 minus j, multiplied by x of n, that is 5, 2, 3, 4. Then find out the multiplication. 5 into 1, 5 plus 2 plus 3 plus 4. Okay, then next is 5 minus 2j minus 3 plus 4j. Then it is 5 minus 2 plus 3 minus 4. Then 5 plus 2j minus 3 minus 4j. The answer is 14. Then 5 minus 3, 2 plus 2j, then 5 minus 2, 3, 3 plus 3, 6 minus 4, 2, and this is 2 minus 2j. So we got the answer of x of k, that is nothing but 14, 2 plus 2j, 2, 2 minus 2j. Okay, so first bit is over. Now we'll move towards second. In second, you must use the result of first one. If you solve by matrix method, it is wrong because it is mentioned in the problem that you must use the result of this one. It means that you must use this particular DFT. Okay, and then only you have to find the DFT of second. Now we'll solve for second. Okay, second bit. Okay, what is x1 of n given? X1 of n given as 4, 5, 2, 3. 4, 5, 2, 3. And what is our x of n? X of n is 5, 2, 3, 4. 5, 2, 3, 4. Now try to find out the relation between the this x1 of n and x of n. See, if you compare the numbers, 4 is there, 5 is there, 2 is there, 3 is there. Okay, so in x of n also. Now check whether it is circularly shifted, time shifted. Try to shift this. 5 shift here, okay, then 2 shift here, and 3, and then 4. So this is nothing but x of n minus 1. Okay, it is circularly shifted, hence it is not going away from this. Whatever number you are getting at the end, that will be replaced by replaced at the first location. So that 4, 5, 2, 3. Check whether it is 4, 5, 2, 3. Yeah, this is nothing but you can find the relation that x1 of n is equal to x of n minus 1. Means it is shifted by 1, means it is delayed by 1. So that use property using circular time shift property. What is x1 of k? If it is shifted, x1 of k is equal to x of k into, see this property, we have seen the property here, circular time shift property. If x of n minus l, then DFT is x of k w n raised to lk. You can have that into w. What is the 4 point w? Lk. L is lk. So you can write x of k into w4 raised to l, means l is 1. Here l is equal to 1. So that 1, and this is k. Okay. Now put k is equal to 0. So x1 of 0 is equal to what? X of 0 into w4 raised to 0. What is x of 0? X of 0 is nothing but this. Here, this particular DFT you must use. So you can use the DFT. X of k is equal to 14, 14, 2 plus 2j, 2 and 2 minus 2j. So this is the DFT of x of k. And this result of that we have to use, means x of 0 is what? 14. X of 1 is equal to 2 plus 2j. X of 2 is equal to 2. And x of 3 is equal to 2 minus 2j. Okay. So that you have to use, means 14 into w raised to 0, w4 raised to 0 is equal to 1. So 14 into 1, so it is answer is equal to 14. Then put k is equal to 1. So what is x1 of 0? x of 1 into w4 raised to 1. So what is x of 1? 2 plus 2j. And what is w4 raised to 1? It is minus j. Okay, w raised to 4. If you are not remembering this, it is 1. This is minus j, minus 1 and j. So it is w4 raised to 0, w4 raised to 1, w4 raised to 2, w4 raised to 3. Okay, so it is minus j. So multiply it, minus 2j plus minus 2j square. So is equal to, this will be plus 2, 2 minus 2j. Then k is equal to 2. x1 of 2 is equal to what? X of 2 into w4 raised to 2. X of 2 is 2 into w4 raised to 2 is 1, minus 1. So answer is minus 2. Then k is equal to 3. x1 of 3 is equal to x of 3 w4 raised to 3. X of 3 is 2 minus 2j. X W4 raised to 3 is j. So answer is 2j minus 2j square. Okay, 2j square. So is equal to 2 plus 2j. So means by using the property, circular time shift property, you got the answer x1 of k is equal to 14 2 minus 2j minus 2 2 plus 2j. So without using DFT matrix, it is now calculated by using the property of DFT. Understood? This is nothing but how DFT property can be used. Here we have used the circular time shift. Means you must find out the relation between the given term and the new term. Okay, relation. If once you find the relation, then you can use the property. Now we'll move towards the third bit of the problem, that is nothing but using result of above, not otherwise. Find DFT of x2 of n is 5432. x2 of n is 5432. What is x of n given? X of n is 5234. 5234. Okay. Now compare both the terms. There are equal number, 5 is there, 4 is there, 3 is there, 2 is there. Okay. Now try to shift it. So 5 2 means whenever you are shifting 5 2 3 4, 5 2 3 4, whether you have 5 2 3 4, no, because it is order is changed. Here you are not getting the same order. In this case you are getting same order. That's 5 2 3 4, 5 2 3 4, 5 2 3 4. Means order is changed. How the order is changed? x2 of n, it is nothing but 5 2 5 4 3 2, and whenever you are comparing with x of n, what you are getting, those two numbers are exchanged. Those two numbers are exchanged. So this property is, what is this property? Exchanging the terms. So it is nothing but it is circularly time reversal or circularly folded signal. So this is nothing but folding property. So it is folded means x2 of n is 5432, where those locations or those numbers are interchanged. So what is the property? By using circular folding property, use circular folding property. Folding property. So you must write the statement of it. What is the property? If suppose x of n is a dt sequence, and x of minus n is folding of it, then x of minus n will have DFT. What is the DFT of that? X of minus k, means it is also folded. What is meant by folding? You have to just interchange the second number with the fourth and fourth with the second. Means this is the second location, this is fourth location, so that there is an interchange between 2 and 4th location. So now you have x2 of n, you can write the relation. x2 of n is nothing but what? X of minus n, correct? It is folded. So that what is the DFT of this? x2 of k is equal to x of minus k. So what is x of k? X of k is 14 2 plus 2j 2 plus 2j 2 minus 2j. Okay. What is the folding of it? You have to just interchange those two numbers. So you will get the answer. So this is nothing but what? The answer is 14. You have to take this number first, that is 2 minus 2j, then 2 and 2 plus 2j. Okay. So this is nothing but x2 of k. x2 of k. So we got the answer by using the property that is called as circular folding property. In case of circular folding property, the second and fourth bit is interchanged and it is represented as x of minus n. Actually it is circularly folded. Because of that, the numbers are not going like this. I will show you explanation for it. What is by circularly folded? Here I will show you. Suppose x of n, this is for your understanding. Okay, 1 2 3 4, and I want to find x of minus n. x of minus n. This is written as x of n minus n, okay, n minus n, where n is equal to 4. So it is x of 4 minus n. Then find out, suppose x1 of n means nu is equal to x of minus n, means I want to find folding of it. So it is equal to, suppose n is equal to 0, x1 of 0 I want to find. This is nothing but x of 4 minus 0. It is equal to x of 4 minus n. So it is x of 4. Is there any value of x of 4? It is 0th location, first, second, third. Fourth means again the first number you will get at the fourth location because of circular shifting. It is repeating, so that you can have 1. Then n is equal to 1. x1 of 1 is equal to what? X of 4 means 4 minus 1, that is x of 3. What is the x of 3? 0, 1, 2, 3, that is 4. Then go for n is equal to 2. x1 of 2 is equal to x of 4 minus 2. So it is x of 2. What is x of 2? 3. And for n is equal to 3, x1 of 3 is equal to x of 4 minus 3. It is equal to x of 1. What is x of n? 2. Now what is the answer you got as the x1 of n? This is nothing but x of minus n, correct? So answer what you got, that is 1, 4, 3, 2. Now compare the two terms. You have just interchanged those two numbers. That is nothing but folding. Okay, understood? So you must identify the relation between original given value as well as what property you can use. So this is, in this particular problem, you have used here as a circular time shift property, circular time shift property, and in second bit you have used circular folding property, circular folding property. Okay, so this is nothing but how you can solve the problems. Now we'll move towards next, that is nothing but problems on next problem, that is convolution property. Convolution property. Now read the problem. Using convolution property of DFT, IDFT, calculate circular convolution of following: x of n is equal to 1231 and h of n is 4322. Now what is the circular convolution property of DFT? You have to write this statement: circular convolution property of DFT is, if suppose x of n having DFT x of k and h of n having DFT h of k, then x of n circular convolution with h of n, the DFT is x of k simple multiplication of h of k, means pointwise multiplication. So this is called as circular convolution property. Now while solving the problem, what you have to do, you have to take x of n, find out DFT that will produce x of k, then take h of n, find out DFT of it, what you will get? H of k. Then multiply them. You can write it as y of k is equal to x of k multiplied with h of k, and this multiplication is pointwise multiplication, one-to-one multiplication. Then after having this multiplication, use IDFT. So that is nothing but you will get answer as y of n is equal to x of k, x of n, circular convolution with h of n. So this is nothing but what property is. So while solving the problem using DFT property, you have to first take x of n, find out DFT, that is x of k, take h of n, find out DFT, that is h of k, and then multiply them together and find out the IDFT. So that is nothing but the how this convolution property of DFT can be used. Now start with x of n. So here it is x of n, you have to take DFT, that is x of k, then h of n, DFT, h of k, and multiply them both. So and then find out IDFT, that is nothing but y of n. Now take x of n. What is x of n given? X of n given as 1231, and h of n is given as H of n is given as 4322. 4322. Okay. Start with the first. Find DFT of x of n. Find DFT of x of n. Use matrix for finding the DFT. So x of k is equal to the matrix DFT matrix multiplied by x of n. So it is 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j multiplied by 1 2 3 1. Now answer is 1 plus 2 plus 3 plus 1 first. Then next is 1 minus 2j minus 3 plus j. Next is 1 minus 2 plus 3 minus 1. 4 is 1 plus 2j minus 3 minus j. So answer is equal to 5 6 7 minus 2 minus j 1 and minus 2 plus j. Minus 2 plus j. Okay, so this is answer we got for x of k. So x of k we got it as 7 minus 2 minus j 1 and minus 2 plus j. Now find out DFT for h of n. Find DFT of h of n. So it is written as h of k. H of k is equal to matrix 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j multiplied by 4322. Okay, let's find out the answer. 4 plus 3 plus 2 plus 2, then 4 minus 3j minus 2 plus 2j, then 4 minus 3 plus 2 minus 2, and then 4 plus 3j minus 2 minus 2j. Okay, so answer is equal to what? 7 9 11. 4 minus 2 2 minus j, then 4 2 to get cancelled 1, then 4 minus 2 2 and j minus means plus j. So answer for this one as h of k is equal to 11 2 minus j 1 2 plus j. Okay, now once you find out the DFT, what you have to do? Find out y of k. Y of k is equal to x of k multiplied by h of k. And here the multiplication you have to do pointwise. Means first value, second value, second value. So write down h of k, that is 7 minus 2, 7 minus 2 minus j, 1 minus 2 plus j. Okay, next is 11 2 minus j, 11 2 minus j, 1 2 plus j. Then multiply. How you can multiply it? Here in case of multiplication, multiply the first term, then multiply second terms, then third terms, fourth terms. So answer for this is 7 into 11, that is 77. Then minus 2 minus j multiplied by 2 minus j. Okay, 1 into 1 1, and then it is minus 2 plus j multiplied by 2 plus j. Okay, so pointwise multiplication you must do. Now calculate the multiplication of this one. Minus 2 minus j multiplied by 2 minus j, so is equal to 2 2 minus 4 minus 2j, then plus 2j, and then jj plus j square. So 2j to j cancel, minus 4, the j square is minus 1, so it is minus 5. Then go for minus 2 plus j, 2 plus j. So answer is 2 2 minus 4, then 2 plus 2j, then minus 2j, and then j into j plus j square, so is equal to minus 4. This get cancelled, j square is minus 1, so minus 5. So you are getting 77, it is equal to minus 5, 1 and minus 5. Okay, after multiplying both. Now apply IDFT. Find IDFT of y of k is equal to, what is the y of k? 77 minus 5, 1 and minus 5. Use IDFT matrix. So y of n is equal to, what is the IDFT matrix? Multiplied by those numbers, that is 77 minus 5, 1 minus 5. It's 1 1 1 1, 1 j minus 1 minus j, 1 minus 1 1 minus 1, 1 minus j minus 1 j. So multiply 77 minus 5 plus 1 minus 5. Okay, next 77 minus 5j minus 1, and this is plus 5j. Then 77 plus 5 plus 1 plus 5, and at last it is 77 plus 5j minus 1 and then minus 5j. Now from these terms, this 5j minus 5j get cancelled, this get cancelled, then you can have the answer 77 plus 1, 78 minus 10, that is 68. Then 77 minus 1, that is 76. Then 77 plus 10, 77, 78 plus 10, 88. And 77 minus 1, that is 76. So you got the answer y of n is equal to 68, 76, 88, 76. Okay, so this is nothing but the answer you got after performing the circular convolution, and you can verify that answer by using your whatever method discussed earlier, that is circular convolution method, for verification. Okay, not for answer, for verification purpose you can use that particular method. So we will use that method here for circular convolution for verification purpose. 1 2 3 1, 1 2 3 1, 1 1 2 3, 3 1 1 2, 2 3 1 1 multiplied by, this is for verification, 4 3 2 2, 4 3 2 2. So do the multiplication. So answer is 4 plus 3 plus 6 plus 2 to 4. Okay, and one more thing is, here we have made one more issue is, it must be multiplied by 1 by 4, because inverse 1 by 4, 1 by 4. So answer you will get 1 by 4, 17, 19, 22 and 19. So answer is 17, 19, 22, 19. This is the answer. This is not answer. 19, 17, 19, 22, 19. Okay. Now you can verify with this method. Then next is 8 plus 3 plus 2 plus 6. Then next is 12 plus 12 plus 6 plus 2 plus 2. And one is 4 plus 9 plus 4 plus 2. So do the calculations. 10, 13, 17, 10, 16, 19, 22, 4, 4, 8, 10, 19. Now see this 17, 19, 22, 19. This answer we got from our method, circular convolution method, that is 17, 19, 22, 19. By using DFT property, we got the answer, that is 17, 19, 22, 19. Means this is nothing but how DFT properties can be used for circular convolution. In time domain method, the circular convolution in time domain, it becomes just multiplication in frequency domain. So we have verified. This is not a part of answer, but for verification purpose, you can use this method, and we have verified by using that method. So whether it is working or not. Now, next problem. Suppose 4-point DFT of a real discrete time sequence x of n is x of k, x of n, DFT is x of k, where k is equal to 0, 1, 2, 3. Given that x of 0 is given 5, x of 1 is given as 1 plus j, x of 2 is given as 0.5, and you have to find x of 3. Now, with the help of symmetry property, we know that if 4-point DFT we have, okay, 4-point DFT, if suppose it is x of 0, it is x of 1, x of 2, and it is x of 3, okay, this is x of 3. Then with the property, it shows that those two values are complex conjugate of each other. Those are complex conjugate of each other. Complex conjugate. It means that if it is a plus ib, then this must be a minus ib in case of 4-point. So that by using that property, x of 3 is equal to complex conjugate of x of 1. So it is 1 plus j, so it will become 1 minus j. So we got x of 3 is equal to 1 minus j. Answer is 1 minus j. Now, if suppose it is 8-point DFT, okay, 8-point DFT, then in case of 8-point DFT, I will tell you how the symmetry property works. X of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and x of 7, okay. Then in case of 8-point DFT, there is also symmetry. This is okay. Then how many numbers are remaining? 1, 2, 3, 4, 5, 6, 7. So middle is 4th. So this will be okay. Then you have to, those are the numbers, means x of 3 and x of 5 are complex conjugate of each other. X of 2 and x of 6 are complex conjugate of each other. And x of 1 and x of 7 are complex conjugate of each other. If suppose in 8-point DFT, the first 5 values are given, then you can easily find out next. That is how you can find out x of 5 is equal to complex conjugate of x of 3. How the x of 6 can be calculated? It is complex conjugate of x of 2. And x of 7 is equal to complex conjugate of x of 1. Okay. So by using that, you can find out any answer. So here is the problem for 4-point. Even for 8-point, you can calculate any values. If the first 5 values are given from the DFT, you can find out the remaining values. And this property can be used while solving the problems also for minimizing the calculations. You can find out the first 5 numbers, and then you can just make complex conjugate into remaining 3 without calculating. So that is also possible. So you can reduce the calculations while finding 8-point DFT by using DFT matrix or using the FFT calculations. Now next point of discussion, that is twiddle factor. So what do you mean by twiddle factor? So discrete Fourier transform formula, if suppose x of n is the input sequence, x of n is dt sequence, then DFT or discrete Fourier transform is represented as x of k is equal to summation n star from 0 to n minus 1 x of n w raised to nk with base n, where w raised to n nk is e raised to minus j 2 pi nk divided by n. So this w n is called as twiddle factor. This is called as twiddle factor. And what is the value of it? E raised to minus j 2 pi divided by n. So this is nothing but called as twiddle factor, Wn. This is called as twiddle factor. Now next question, we will use Parseval's energy theorem. Okay, Parseval's, or we will verify Parseval's energy, Parseval's theorem. What is Parseval's theorem? We have discussed in earlier this one, Parseval's energy theorem. That is nothing but if let x of n is dt sequence, then x of n having DFT x of k, then summation n star from 0 to n minus 1 x of n bracket square is equal to 1 upon n summation k star from 0 to n minus 1 x of k bracket square. It means that the energy in time domain, it is nothing but the energy equal to 1 by n divided by 1 by n multiplied by the summation of x of k bracket square. So we'll verify this particular problem by using Parseval's energy theorem. Now the statement is, suppose let verify Parseval's theorem for x of n is equal to 1 2 3 4 1 2 3 4. Okay, now see how that works. Now first of all, what is the Parseval's theorem? Summation n start from 0 to n minus 1 x of n bracket square, it is equal to 1 upon n summation k start from 0 to n minus 1 x of k bracket square. This is nothing but magnitude. Okay, magnitude. Now find out x of n square summation n start from 0 to n minus 1. So is equal to, it is nothing but the value raised to 1. For 0, it is x of 0. So it is 1 square plus 2 square plus 3 square plus 4 square. Okay, so it is 1 plus 4 plus 9 plus 16. The answer is 1 plus 4 5, 5 plus 9 14, 16 30. So first we got answer as 30. Summation n start from 0 to n minus 1 x of n bracket square. So it is 30. Now find out x of k. X of k by using DFT matrix you can find 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j multiplied by the values as 1 2 3 4. So what is the DFT of it? 1 plus 2 plus 3 plus 4, 1 minus 2j minus 3 plus 4j, 1 minus 2 plus 3 minus 4, and 1 plus 2j minus 3 minus 4j. So answer is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, now this is nothing but x of k. Now find out the sum 1 upon n summation k start from 0 to n minus 1. That is nothing but magnitude. We have to find the magnitude of this. This is not a magnitude, it has magnitude as well as angle. So how to find the magnitude of it? X of k, magnitude, how it can be found out, is equal to first value. How to find the magnitude of the complex number? The magnitude is found out as a square root of a square plus b square. Okay, and what is the angle of this? Theta is equal to tan inverse of b by a. Okay, so this is nothing but how magnitude and the angle will be calculated. So we are calculating the magnitude, so 10, so it is square root of 10 square. Next number is minus 2 plus 2j. So from this, minus 2 is the one number and 2 is the another number, so we will write as square root of minus 2 square plus 2 square and square root of that. Next, then minus 2 square raised to square root, and last it is minus 2 minus 2, so minus 2 square plus minus 2 square and then square root of it. So that is the magnitude we have. So 10, answer is 10. Then the magnitude of this is square root of 2 raised to 2 4 plus 4, then this is 2 raised to this 4, and this is equal to 4 plus 4. So is equal to 10 square root of 8, then 4 is 2 square root of 8. Okay, so we got this. Now find out 1 by n summation then it is nothing but we'll find out 1 by n summation x of k bracket square. So 1 by n, 1 by 4 summation x of k square, that is 10 plus the this one is 8 square, means 8 plus 2 raised to 4 4 plus 8. So it is 1 by 4, 100 plus 16 plus 4. So it is 1 by 4 into 20, 120, 120. So 4 3 is 30. So we got 1 upon n summation k start from 0 to n minus 1 x of k bracket square is equal to 30. So this is equation number 2. Now compare both. What is the answer you got? 30. And by using the DFT also you got the 30. So from those two equations we can say that from equation 1 and 2 we can say that summation n start from 0 to n minus 1 x of n small x of n bracket square is equal to 1 upon capital N summation k start from 0 to n minus 1 x of k bracket square. So this is nothing but how the Parseval's energy theorem we have satisfied or we have derived. Okay. Now after Parseval's energy theorem, one more question I would like to solve, that is nothing but finding magnitude and phase of DFT. Suppose the question is for x of n is equal to 1 2 3 4, find magnitude and phase of x of k, magnitude and phase of x of k. So first of all, what you have to do, calculate DFT of x of n. So x of k is equal to 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j multiplied by number 1 2 3 4. So the answer comes to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Now once it is calculated, you have to calculate magnitude. So magnitude is represented as, this is nothing but magnitude of x of k. Okay. So how to calculate magnitude as per the previous problem? So it is nothing but 10 square, then square root of minus 2 square plus 2 square, third value is minus 2 square, and fourth it is minus 2 square plus 2 minus 2 square. So this is the magnitude of it. So answer is 100, means it is 10. Answer is 10. This is square root of 8, then it is 2 and square root of 8. So you can have the square root of 8. So this is nothing but called as magnitude of it. Now you can calculate the phase of this one. How to calculate the phase? For calculation of phase, it is represented as x of k. Okay. So is equal to first value tan inverse of b by a. B is 0 divided by 10. So answer tan inverse of 0. Then tan inverse of 2 divided by minus 2. Then tan inverse of 0 divided by minus 2. And tan inverse of minus 2 is 2 by 2. So if you find the angle by tan inverse of 0, what is tan inverse of 0? Tan inverse of minus 1, this is tan inverse of 0, tan inverse of minus 1, tan inverse of 0, and tan inverse of 1. Then you will get the phase of it. This is the angle. Phase means angle. So you can calculate the phase of it. This is nothing but how you can calculate magnitude and phase. So we have solved many problems on properties. Also we have seen how to calculate magnitude, phase, how to derive the Parseval's energy theorem, then what is twiddle factor, how this symmetry property will be used, how that convolution can be solved by using property. Then we have solved, we have used circular folding property, and we have used circular time shift property. Okay, so we'll stop here.